Picture 800 terabytes of invoice PDF sitting in S3, billed at full standard rates. That's $230,000 a year. The exact same files, still instantly readable, can cost $45,000 instead. Nothing about the data changed, only where it sits did. Stack lessons here. I'll prove that in the next few minutes. By the end of this video, you'll be able to pick the right S3 storage class straight from a workload's access pattern and retrieval requirement, and automate the whole thing with lifecycle policies. The decision almost always comes down to two qualifiers. How fast do you need the data back, and how often will you read it? Back in the S3 security episode, we locked down MegaCorp's buckets with block public access, bucket owner enforced ownership, and server-side encryption using KMS, the key management service. Those supplier contracts and invoice PDFs are safe now, but the exact same objects are still costing full price. Every one of them is billed at S3 standard rates, and that's the problem we're solving today. Before we go further, 5 terms worth anchoring. A storage class is a tier of S3 storage. Each step down the ladder costs less per gigabyte, but retrieval gets slower or more expensive. Intelligent tiering is the class that watches your access patterns and moves objects between tiers for you, charging no retrieval fees along the way. Glacier Instant Retrieval sits in archive territory on price, but still hands data back in milliseconds. A lifecycle policy is a bucket-level rule set that handles those tier transitions automatically based on object age. And minimum storage duration is the billing commitment attached to colder classes. Delete early, and you still pay for the full period. Here's the shape of MegaCorp's problem. A fresh invoice gets read constantly the first month, while the finance team reconciles payments. After that, it's read weekly during audits, then quarterly at tax time, then, honestly, almost never. But it has to stay for 7 years. And the whole 7 years, it's sitting in S3 standard, priced as if someone's reading it every day. The access pattern cools down over time. The storage class never moves. That mismatch is exactly what costs the money. Here's the core idea behind every storage class. Cheaper storage is never free money. You pay for it one of 2 ways. Either the data comes back slower, sometimes hours slower, or you get charged a fee every single time you read it. The whole game is matching how you access data to a class where those trade-offs don't hurt you. Think of the classes like a library. Standard is the main reading room. Rent is high, but access is instant and there's no fee to grab a book. Standard IA is the basement stacks. Rent is cheaper. Books are still on hand instantly, but you pay a small fee each time you check one out. Glacier Instant is the off-site warehouse. Rent is very cheap, delivery is still instant, but the delivery fee is higher. And Deep Archive is the underground bunker. Storage is pennies per book, but retrieving one takes 12 to 48 hours. Now put the whole spectrum in front of you, running from hot and costly on the left to cold and cheap on the right. Standard sits on the far left at about 2.3 cents per gigabyte, with millisecond access and no fees. Standard IA is cheaper per gigabyte, still instant, but it adds a 30-day minimum and a retrieval fee. Glacier Instant Retrieval drops the storage rate way down, around 0.4 cents, and still reads in milliseconds. Glacier Flexible Retrieval is cheaper again, at roughly 0.36 cents per gigabyte, but now you must run a restore job. And Deep Archive is the floor, under 0.1 cent per gigabyte, with retrieval measured in hours. One thing that does not change anywhere on this line: durability is 11 nines across every S3 storage class, one zone IA included. What one zone IA gives up is not durability, it's resilience. Store data in a single availability zone, and you're exposed if that zone has a physical failure. Only availability, resilience, and cost shift as you move right. There are actually two infrequent access flavors, and one word separates them. Standard IA spreads your data across 3 or more availability zones, so it survives a zone failure. That's the one for primary copies of irreplaceable data. One zone IA keeps everything in a single zone, which makes it roughly 20% cheaper, but if that one zone fails, the data is gone. So one zone IA is only ever the right answer for reproducible data. Think thumbnails you can regenerate, or secondary backups where the real copy lives somewhere else. Both share the 30-day minimum and the retrieval fee. Quick recap on the warm end of the spectrum. Standard is for frequent access, no penalties, but the highest storage rate. Standard IA gives you instant access at a lower rate, with a 30-day minimum and a retrieval fee. One zone IA has the same terms but a single zone, cheaper, and only for reproducible data. Now let's move into the cold archive tiers, where the decisions get more interesting. Glacier isn't one thing. It's 3 tiers, each with a different job. Instant retrieval gives you archive-level pricing, but reads still come back in milliseconds. The mistake people make is assuming all 3 feel the same. They don't. Only one of them hands you data instantly. Flexible retrieval is cheaper, but you have to run a restore job first, and that takes anywhere from minutes to hours. Deep archive is the cheapest of all, and its restore takes 12 to 48 hours. Picture the 3 Glacier tiers as 3 kinds of safe. Instant retrieval is a fireproof safe right in your office. You walk over and open it in seconds. Flexible retrieval is a bank safe deposit box. You have to visit the branch, and standard access takes 3 to 5 hours, though you can pay to expedite. Deep archive is a vault buried 1,000 feet underground, where retrieval takes 12 to 48 hours. The pattern is simple. The cheaper the storage, the longer the trip to get your data back. Here's the key rule for Glacier. If data is archived and rarely touched, but must come back in milliseconds when someone does need it, choose Glacier Instant Retrieval. Not flexible, not deep archive. The word milliseconds rules both of those out because they require a restore step that takes minutes to hours. Instant retrieval is the only archive class that skips that step entirely. Amazon Web Services is refreshingly direct about this in the docs. Glacier Instant Retrieval, they say, is the lowest cost storage for long-lived data that's rarely accessed and requires retrieval in milliseconds, saving up to 68% compared to standard IA with the same latency and throughput. That last part is the key. Same speed as standard IA, but 68% cheaper to store, as long as your reads are genuinely rare. This is the distinction that trips people up. Flexible retrieval and deep archive are not real-time storage. You can't just do a get and read the bytes. You have to call the restore object operation, wait for the data to be staged into a readable copy, and only then can you download it. That waiting period is minutes to hours for flexible and up to 2 days for deep archive. Let's line up the retrieval times so the gap is obvious. Glacier Instant is a direct get, so you're in the millisecond range, effectively no wait. Flexible retrieval gives you 3 choices. Expedited comes back in 1 to 5 minutes, and you pay for it. Standard lands in 3 to 5 hours. Bulk takes 5 to 12 hours. And here's the nice part. Bulk on flexible is free. Deep archive sits at the far end, 12 to 48 hours regardless. Notice how everything except instant is measured in hours, not milliseconds. So when do you pick flexible over deep archive? Flexible retrieval is the backup and disaster recovery class. Its standout feature is free bulk retrieval in 5 to 12 hours, which is perfect when you need to restore a big batch without paying retrieval fees, and it has a 90-day minimum. Deep archive is for compliance, tape replacement, data access less than once a year. It's the cheapest class on Amazon Web Services at under 1/10 of a cent per gigabyte. But every retrieval tier is charged. Retrieval takes 12 to 48 hours, and the minimum jumps to 180 days. The trigger words are hours acceptable versus days acceptable. The docs put a fine point on it. Flexible retrieval and deep archive objects are archived and not available for real-time access. You must first restore archived objects before you can access them. So anytime a scenario demands real-time or latency-sensitive reads, both of these classes are automatically wrong, no matter how cheap they look. Let's lock in the cold tiers before we move on. If you need milliseconds on archived data, that's Glacier Instant Retrieval. If you can wait hours and want free bulk restores, that's Glacier Flexible Retrieval. And if the data's accessed less than once a year, days are fine, and you want the rock bottom price, that's Deep Archive. But all of these assume you know your access pattern. What about when you genuinely can't predict it? That's the next class. Intelligent tiering is the class that does the thinking for you. It watches each object individually, and as access patterns change, it shuffles that object between tiers on its own. An object that goes untouched for 30 days drops to the infrequent access tier automatically. After 90 days of no access, it moves into the archive instant access tier, and that happens automatically too, no configuration required. The archive access and deep archive access tiers are different. Those are optional and must be explicitly activated. If you do enable them, objects that remain untouched for 90 or 180 days respectively can move down into even colder archive pricing. You pay a small monitoring fee per object, but there are no retrieval fees and no minimum duration. So when a scenario says access patterns are unknown or changing over time, this is almost always the answer. Straight from Amazon Web Services, intelligent tiering is the only storage class that delivers automatic cost savings by moving data at the individual object level between access tiers when patterns change, and there are no retrieval fees. Those are its two killer features: automatic optimization and no penalty when you do read the data. That combination is why it wins the unknown pattern question every time. Intelligent tiering has one catch worth knowing. Objects smaller than 128 kilobytes are never auto-tiered. They stay in the frequent access tier permanently, regardless of how rarely they're touched. They don't incur the per-object monitoring fee. Amazon Web Services removed that charge for small objects back in 2021, but they also never moved to a cheaper tier. So for a bucket dominated by lots of tiny files, you get no tiering benefit at all. That's when a different storage class, chosen deliberately, will serve you better. Intelligent tiering handles the unknown. Lifecycle policies handle the known. A lifecycle policy is a set of declarative rules on the bucket that transition objects to colder classes or delete them outright, based purely on how old they are. Two things to hold on to. First, transitions are one way. You go hot to cold, never back to a warmer class automatically. Second, there's no application code involved. You set the rules once, and they run forever, on a conveyor belt that never stops. Use Lifecycle when you know the schedule your data follows. Use intelligent tiering when you don't. Now let's build MegaCorp's actual policy and watch an invoice age through it. For the first 30 days, it lives in standard, read constantly while finance reconciles the payment. At day 30, it transitions to standard IA because now it's only pulled up weekly for audits and it's still instant. At day 90, it drops to Glacier Instant Retrieval since it's down to quarterly tax prep, but it still returns in milliseconds when someone needs it, at a fraction of the cost. And at year 7, when the compliance window closes, the lifecycle rule expires the object and it's gone. One policy, 4 stages, no code. Here's that same policy as JSON, and there's one detail worth burning into memory. Look at the storage class values. Glacier_IR means instant retrieval, millisecond access, no restore step. Plain Glacier with no suffix means flexible retrieval, which takes hours and requires an async restore before you can read the data. Teams have shipped this to production, expecting instant reads, written plain Glacier when they meant Glacier_IR, and found every read sitting in a multi-hour restore queue. The decision rule is straightforward. If you need millisecond access, the storage class value must be Glacier_IR, not plain Glacier. One property of Lifecycle rules catches a lot of people off guard. They're retroactive. When you add a Lifecycle configuration to a bucket, it applies to objects that are already there, not just future uploads. So if you add an expiration rule today that deletes objects older than 30 days, S3 immediately queues up every existing object that's already past 30 days for removal. A rule you write this afternoon can act on data you uploaded years ago. And here's the part that makes retroactivity genuinely dangerous. A bucket policy cannot stop a Lifecycle rule. Amazon Web Services is explicit about this. Even if your bucket policy denies every action for every principal, your Lifecycle configuration still runs as normal. So you can't lean on IAM or a bucket policy as a safety net against an accidental Lifecycle deletion. The only safety net is testing your rules carefully, ideally in a non-production bucket first. Now the pricing pitfalls, because these are what turn a clever cost move into a bigger bill. There are 4 minimum duration charges. Delete an object early and you still pay for the full 30, 90, or 180 days. Retrieval fees. Read cold data often enough and the fees can swallow your storage savings whole. Small object overhead. A 10 kilobyte file in IA or a Glacier Instant is billed as if it were 128 kilobytes. So moving lots of tiny files to infrequent access classes can actually cost more. And version buckets. Expiration only hides the current version, so the old versions keep billing. Let's look at the ones that catch the most people. The docs spell out 2 of these penalties in one breath. If an object is less than 128 kilobytes, Amazon S3 charges you for 128 kilobytes. And if you delete an object before the 30-day minimum, you're charged for the full 30 days anyway. Put those together, and small, short-lived files are exactly the wrong thing to push into an infrequent access class. Think of the minimum like a gym contract. Cancel after 10 days, you still owe the full month. Here's a real mistake that shows all of this at once. A team pushed their application logs to standard IA after 7 days, trying to save money. But the debugging team read those logs many times a day, so retrieval fees stacked up fast. And when they deleted the logs at day 10, they still got billed for the full 30 days. The net result was roughly 3 times more expensive than doing nothing. The right move was to leave short-lived, frequently read data in standard. No retrieval fees, no minimum penalty. Delete at day 14 and pay for 14 days. The rule of thumb, if data lives under 30 days or gets read often, keep it in standard. One last hidden cost, and it's a sneaky one. In a version bucket, an expiration rule doesn't actually delete anything. It just adds a delete marker over the current version. The older versions are still sitting there, still being stored, still being billed. Teams have discovered months later that terabytes of supposedly deleted data were quietly costing them money. To truly stop paying, you need a separate non-current version expiration rule that purges those old versions. Let's collapse everything into one decision tree you can carry into the exam. Start with the access pattern. If it's unknown or changing, stop. The answer is intelligent tearing. If the data gets deleted in under 30 days, keep it in standard. If it's reproducible data you could recreate, one zone IA saves you 20%. And if you're archiving, ask one more question. How fast must you read it back? Milliseconds points to Glacier Instant. Hours with free bulk restores points to Glacier Flexible. And days acceptable, lowest possible cost points to Deep Archive. Every arrow on this tree comes down to a single qualifier in the question. And here's the payoff for MegaCorp. Leaving everything in standard costs them about $230,000 a year. With one lifecycle policy walking invoices from standard to standard IA to Glacier Instant, and finally expiring them at year 7, that drops to roughly $45,000. That's around an 80% cut, and every invoice stayed instantly readable the entire time. No servers, no code, just rules matched to how the data actually gets used. Carry these 5 rules forward. Archive data that must read back in milliseconds means Glacier Instant Retrieval. An unknown or changing access pattern means intelligent tiering, with its no retrieval fees and no minimum. Short-lived or frequently read data stays in S3 standard. Lifecycle policies automate the transitions and the expiration, but remember they're one-way and retroactive. And the decision rule that ties it all together: total cost is storage plus retrieval plus any minimum duration penalties, not just the sticker rate per gigabyte. Now let's see how well that stuck with a quick 5-question quiz. Question 1. Hospital stores radiology scans that are accessed rarely once they pass 90 days, but when one eye requested for emergency care or a legal defense, it must come back in milliseconds with no restore delay. Which class fits best? A. Glacier Deep Archive. B. Glacier Flexible Retrieval. C. Glacier Instant Retrieval. Or D. S3 Standard. Run the decision rule from earlier before you answer. This one is C. Glacier Instant Retrieval. The words milliseconds and no restore delay knock out both flexible and deep archive, since both need a restore call first. Standard would work but waste money on data that's rarely touched. Instant retrieval gives archive pricing with millisecond reads, exactly the bridge this scenario needs. Question 2. A media company has 10 petabytes of raw video footage. Some files get licensed years later, most are never touched again, and there's no way to predict which is which. They want cost savings without managing lifecycle rules or paying retrieval fees. What should they use? A. Standard IA with a lifecycle policy. B. Intelligent tiering. C. One zone IA. Or D. Glacier Flexible Retrieval. Pause here if you want more time. The right call here is B. Intelligent tiering. The phrase "no way to predict" is the tell. When access is unknown or changing, and they explicitly want to avoid retrieval fees, intelligent tiering is the answer. It moves each object between tiers automatically, and it never charges a retrieval fee. A fixed lifecycle policy would just be guessing at a pattern nobody can predict. Question 3. A team transitions 7-day application logs to standard IA to cut costs. The debugging team reads these logs many times a day, and the logs get deleted after about 10 days. What's the most likely outcome? A. Costs rise because retrieval fees plus the 30-day minimum exceed the savings. B. Costs drop roughly 45% from cheaper storage. C. Costs are unchanged since S3 prorates fairly. Or D. The logs become unreadable until a restore completes. Think about which constraint matters most here. The answer is A, and here's why. 2 penalties stack up. The frequent daily reads each trigger a retrieval fee, and deleting at day 10 still gets billed for the full 30-day minimum. Standard IA reads are instants, so D is wrong, and the proration in C ignores the minimum charge entirely. For short-lived, frequently read data, standard is actually the cheaper haul. Question 4. In a versioned S3 bucket, a team adds a lifecycle expiration rule expecting it to stop billing for old data. A month later, They're still paying for terabytes they thought were deleted. What did they miss? A bucket policy was blocking the rule. B, lifecycle rules don't apply to pre-existing objects. C, expiration rules don't work with SAA-C03. Or D, expiration only adds a delete marker, so they need a non-current version expiration rule. Lock in your answer before I give it away. If you said D, well done. In a version bucket, an expiration action just drops a delete marker over the current version. The older versions stay stored and keep billing. Bucket policies can't block lifecycle rules, so A is out. Lifecycle rules are retroactive, which kills B. And encryption is irrelevant here, so C is wrong. You need a non-current version expiration rule to actually purge those old versions. Question 5, and let's test a concept from an earlier episode. Recall that MegaCorp enforces SAA-C03 on all uploads to its contracts bucket using an explicit deny bucket policy. If they later add a lifecycle rule to expire contracts after 7 years, does that bucket policy protect the objects from the lifecycle deletion? A, yes, the explicit deny overrides all delete actions including lifecycle. B, yes, but only if versioning is disabled. C, no, bucket policies cannot prevent lifecycle deletions and the rule still runs. Or D, no, because SAA-C03 objects are exempt from lifecycle. Got your pick? Let's see. The answer is C. Amazon Web Services states it plainly. Even a bucket policy that denies every action for every principal cannot stop a lifecycle rule from executing. This is exactly why you test lifecycle rules carefully, because unlike the explicit deny that guards your uploads, nothing in IAM or a bucket policy stands between a lifecycle expiration and your data. Versioning and encryption don't change that, so B and D are both wrong. That's a wrap on cost-optimized storage, S3 classes, and lifecycle policies. Subscribing is the simplest way to help these reach more learners studying like you, so please do. Drop your feedback in the comments. All of it is useful. If there's a cert you want me to build next, suggest it below. And tell me how the pacing and visuals are landing. Catch you in the next lesson.